All right, hey there, 7th graders. Welcome to this special exam prep explainer. I'm your host, but you know what? Today, I'm putting on my hard hat. I am stepping in as your guest teacher and your resident geologist. We are going to review absolutely everything you need to know for your big geography exam on Chapter 2, Inside Our Earth. Now, I know studying can sometimes feel like, well, digging through solid rock. But today, we're going to break it all down, make it super easy to remember, and honestly, we're going to have a lot of fun doing it. Okay, let's dive right in. 6,371 kilometers. Just let that sink in for a second. That is the radius of the Earth. It's literally massive. As a geologist, one of the most common questions I get from students is, hey, why can't we just dig a hole straight to the center of the Earth to see what's down there? Well, to put that into perspective, the deepest mine in the entire world is located in South Africa, and it only goes about 4 kilometers deep. Engineers who drill for oil, they've only managed to get about 6 kilometers down. To actually reach the center, you'd have to dig over 6,000 kilometers deep, straight through the ocean floor, where temperatures are so insanely hot that solid rock just melts. So since we can't physically dig our way down there, we rely on science to figure out what's beneath our feet.
So here is our study guide roadmap for today. Consider this your mental checklist for the exam. We'll start with the layers of the Earth, then move on to the 3 rock types and the dynamic rock cycle. After that, we'll look at rocks in daily life, and we'll wrap the whole thing up with a rapid-fire pop quiz. Let's do this.
First up, Section 1, Layers of the Earth, Peeling the Planetary Onion.
Our Earth is this incredibly dynamic planet, right? It's constantly changing inside and out. And really, the absolute best way to picture its interior is to just imagine peeling a giant onion. It's made up of several concentric layers, neatly stacked one inside the other. You've got 3 main layers going from the outside all the way to the deep center: the crust, the mantle, and the core. So whenever you see a question on your exam about Earth's structure, I want you to literally close your eyes and picture this exact onion-like arrangement. Now let's break down the specific details you're going to need to memorize.
Okay, so knowing the differences between these layers is absolutely crucial. Consider this your ultimate exam cheat sheet. The crust is our topmost layer. On land, the continental masses, it's about 35 kilometers thick and made primarily of silica and alumina. Now, here is a massive study hack for you. Combine Cl for silica and alumina, and boom, you get Cl. Simple, right? On the ocean floor, the crust is much thinner, only about 5 kilometers, and it's made of silica and magnesium. So combine Cia and Maga, and you get Cima. Got it? Right beneath the crust is the mantle, which drops down a whopping 2,900 kilometers. And finally, the deepest layer is the core, boasting a radius of about 3,500 kilometers. It is under extreme pressure and heat down there, and it's mostly made of nickel and iron, or ferrous. Combine Ni and Fe, and what do you get? Nife. Just remember Cl, Cima, and Nife, and you will totally ace this section.
All right, let's put that fresh knowledge to the test right now. True or false? The crust is the thickest layer of the Earth. I'm going to give you a quick second to lock in your guess. Think back to those numbers we literally just talked about. If you guessed false, you are completely right. No way is it the thickest. The crust is actually the thinnest layer, making up just a tiny 1% of the Earth's total volume. The mantle is the real heavyweight, dominating at an incredible 84%, and the core fills out the remaining 15%. Because the crust is where we live and build our cities, it feels enormous to us, right? But in planetary terms, it's just a sliver. It's kind of like the thin skin of an apple.
Moving right along to Section 2, the 3 rock types, a geologist's guide to the crust.
Now that we know all about the crust itself, let's talk about what actually makes it up. The Earth's crust is built out of natural masses of mineral matter that we call rocks. There are 3 main categories, and I've got another huge study tip for you here. If you learn the Latin and Greek root words for these rock names, you'll instantly know exactly how they're formed. Check this out. Igneous comes from the Latin word ignes, which literally means fire. So these rocks are born from fiery, molten magma. Sedimentary comes from the Latin word sedimentum, meaning to settle down, because these rocks form from little particles settling and squeezing together. And metamorphic, that comes from the Greek word metamorphos, meaning to change form. These are rocks that literally morph, like a superhero, into something totally new.
Let's zoom in on those fire-born igneous rocks, which we often call primary rocks. They form when molten magma cools down and solidifies. But, and this is key, there are 2 different ways this happens, and it completely changes how the rock feels and looks. If molten lava erupts out of a volcano and spills onto the Earth's surface, it cools down extremely fast. This creates extrusive igneous rocks, which have this very fine-grained, smooth structure. Basalt is a classic example. Fun fact, the entire Deccan Plateau in India, made of basalt. Now, on the flip side, if the magma cools slowly, trapped deep inside the Earth's crust, it forms intrusive igneous rocks. Because they cool down so slowly, they form really large grains. A perfect everyday example of this is granite.
Over thousands of years, rocks roll around, crack, and smash into each other, breaking into tiny fragments called sediments. Wind and water act like natural delivery trucks, transporting these sediments, depositing them, and eventually they compress and harden into sedimentary rocks, like sandstone. And here's something awesome. Because they form in stacked layers over time, sedimentary rocks are the exact ones where you usually find the fossils of ancient plants and animals. Pretty cool, right? Now, what happens if you take an igneous or a sedimentary rock and shove it deep underground where there is intense heat and crushing pressure? It physically transforms into a metamorphic rock. For instance, basic everyday clay changes into slate, and limestone, it morphs into gorgeous marble, all thanks to that heat and pressure.
Section 3. The Dynamic Rock Cycle. Earth's Ultimate Recycling System. Okay, here is a mind-blowing concept that is guaranteed to be on your exam. Rocks do not stay the same forever. Never. The Earth runs this incredible continuous recycling loop. Here's how it flows. Molten magma cools to form igneous rock. Over time, weathering breaks that rock down into little sediments, which are then transported and squeezed together to form sedimentary rock. If that sedimentary rock gets buried deep enough, intense heat and pressure transform it into metamorphic rock. And if that metamorphic rock gets pushed down even deeper, it just melts right back into magma and the whole shebang starts all over again. Memorize this exact flow for your exam and you will absolutely nail any rock cycle question they throw at you.
On to Section 4, Rocks in Daily Life. Let's look at some real-world geology.
Now, you might be sitting there wondering, okay, this is cool science, but what does it actually have to do with me? Well, geology isn't just trapped inside your textbook, it is literally everywhere around you. We rely on hard rocks to build our roads, our houses, our entire cities. If you peek into a traditional kitchen, the grinding stones used to crush spices are almost always made of granite, and we know that's an intrusive igneous rock. Look at massive monumental architecture. The spectacular Red Fort is built using red sandstone, which is a sedimentary rock. And the world-famous Taj Mahal, it's constructed entirely from pure white marble, a metamorphic rock. You even use rocks to play games like Pithu or Seven Stones. So yeah, geology is a huge part of your daily life.
Section 5, Exam Prep Pop Quiz. Time to test your knowledge.
Let's see just how much of this explainer has stuck in your brain. I actually pulled a few practice questions straight from real class worksheets. Don't be shy, go ahead and shout the answers right at your screen. Question 1, the thinnest layer of the Earth is A, crust, B, knife, C, core, or D, mantle. Lock it in. Boom! The answer is A, crust. Remember that donut chart we looked at? It only accounts for 1% of the Earth's volume and is roughly 5 to 35 kilometers thick. Awesome job! Moving on. Question 2. Where is the deepest mine in the world located? Is it South America, South Africa, South India, or South Australia? Think back, we talked about this right at the very beginning. Spot on. The answer is South Africa. And hey, bonus points for your exam if you can remember that it's only about 4 kilometers deep, which really just proves we've barely scratched the surface of our own planet. Okay, question 3. When molten magma cools down deep inside the Earth's crust and forms solid rocks, what are they called? Is it intrusive sedimentary, intrusive metamorphic, extrusive igneous, or intrusive igneous? Nailed it. The answer is D, intrusive igneous rocks. Remember our golden geologist's rule? If it cools deep inside, it's intrusive. And because it cools super slowly, it forms nice large grains. Like our friend, granite. Let's rapid fire these last 2 questions to finish strong. Rocks containing fossils are called what? Sedimentary rocks, for sure, because those fossils get perfectly trapped right between the layers of sediment. And finally, the absolute innermost layer of the Earth is the core, packed with super hot iron and nickel. Man, you guys are going to absolutely crush this exam. Well, I really hope this explainer has made studying the Earth's layers and rock cycles a whole lot easier and, honestly, a bit more fascinating. Geology is just the epic story of our planet constantly remaking itself. So I'm going to leave you with this final thought. The very next time you step outside, look down at the ground. What kind of rock do you think is hiding right under your feet right now? And what kind of crazy, incredible geological journey did it take to get there?
Good luck on your 7th grade geography exam, stay super curious, and keep exploring.